Back to PreCalc Lesson 2.6. Yesterday we looked at solving polynomial inequalities. Now we are looking at solving rational inequalities. Rational inequalities are just like, very similar to solving polynomial inequalities. However, in addition to including zeros on the sign chart, because that's what we did for polynomial inequalities, we must include vertical asymptotes, because usually the sign changes on the opposite side of a vertical asymptote. We can see that right here. So yes, we want to know zeros, because when on the opposite side of the zero, sometimes the signs change, sometimes they don't. And on the opposite sides of vertical asymptotes, sometimes the signs change, sometimes they don't. So we have to consider all of that. Looking at this example right here, I'm going to factor as much as I can. So I have 2 by 3x minus 4 in my numerator, and I have x minus 3 by x minus 6 by x plus 1 in my denominator, because they have to add to -5 and multiply to -6. So none of them cancel. There are no holes. Oh, I should put that down too. We must include vertical asymptotes and holes on our sign chart. And those will not have equality because the function doesn't even have equality at those values. So we do know where our 0 is. Our 0 is going to be x equals 4/3. We will have two vertical asymptotes, one at x equals 6 and one at x equals -1, knowing this from lesson 2.5. So on my sign chart, this does have equality, but only with the zeros. It does not have equality with the vertical asymptotes because they're not part of they're excluded from the domain of the function. So I need to plot 4/3, which is 1 1/3. And 6 and -1 on my sign chart. The only one that can be included because it has equality is the 4/3. Yesterday you were only concerned about whether the 0 had equality or didn't. If it didn't, we put an open circle on the graph. If it did, we put a closed circle. But that was for the zeros of a polynomial function. For rational functions, the inequality is only applied to the 0. The vertical asymptotes and any holes have to go as open circles because they don't have equality. Now, we're asked, where is this rational function greater than or equal to 0? So we're going to put the function into our calculator for y equals. We have 6x minus 8 divided by in parentheses, x squared minus 5x minus 6. And so I go to my table and I put in -2 and I get a negative output. And I go between -1 and 1.5, so I'm going to do 0 and I get a positive output. And I go between -4/3 and 6 and get a negative output. I go to the right of 6 and get a positive output. Once again, you cannot trust that your signs will always alternate. You need to check between every asymptote, every hole, and every 0 on both sides of them to make sure you get an accurate sign chart before you write your answer. We want to know where the output is greater than or equal to 0. So we're happy if it is equal to 0, and we're happy if it's greater than. So our intervals will be from, but not including -1, up to and including 4/3, and from but not including 6 to infinity. Over these intervals, this rational function is greater than or equal to 0. I'm going to give you two more examples, so I'm saving some room at the bottom because I don't have it typed, but we need to include a third example on here. So we have this, and it's an important one. This one is very similar to the last one. This one does have oh, this one had a horizontal asymptote, but I wasn't concerned about the horizontal asymptote except for the end behavior. So going back to the previous lesson, lesson 2.5, if there's a horizontal asymptote, that's going to affect our end behavior. And I'm not going to review that right now, but you may need to go back and look at that, because for these functions, rational functions and even rational inequalities, you may be asked to describe the end behavior. It'll be the same as it would be as if this were equal to f of x. All right, on this rational function, no, I don't need to add a third example. It's right here. This is not less than 0, and I need to make it so. So I have x squared minus x minus 11 over x minus 2 minus 3 is less than 0. Now, if I were solving this as an equation, I would just have left the 3 over there and multiplied by the least common denominator, because I would be solving for x. That is not what we're doing right now. We have to be careful as we approach this function. So we have to approach it like we approached this one. I need to get this as part of this fraction. So in order to do that, I need its denominator, which right now is 1, to be x minus 2. So I'm going to multiply both the top and bottom of the negative 3 by x minus 2, giving me negative 3x, negative 3 times negative 2 is plus 6. Be very careful, make sure you distribute the sign as well, over x minus 2. So now that they have the same denominator, I can combine them. So I have x squared minus 4x plus 2 all over x minus 2. We can find our zeros from this function. We probably will have to use the quadratic formula. So opposite of 4 over 2 plus or minus the square root of b squared minus 4 times a times c is 8. So that'll be 2 square roots of 2, also over 2. So this will be 2 plus or minus the square root of 2. So I have 2 plus the square root of 2. I have, which by the way, is roughly 3.14. I have a vertical asymptote at, oh, and I'm going to do an open circle, even though normally it would be a 0. I'm going to do an open circle because it does not have equality. I'm going to do one at negative 2, or 2 minus the square root of 2. And I'm also going to do an open circle because of the vertical asymptote at x equals 2. I now will do my sign chart to determine the inequality for which this is less than or equal or less than 0. So I have in the numerator x squared minus 4x plus 2, and in the denominator x minus 2. When I go to my table, I put in 2 minus the square root of 2, which gives me 0. I don't want that. I want to go to the left of that. So that is 0.5, so I'm going to go to 0, which is negative. Between that and 2, I'll use 1. That gives me a positive sign. Between 2 and 2 plus square root of 2, which is 3 point something, so I can do 3. I get a negative sign. And to the right of 3 point something, I'll do 4. I get a positive sign. So this function asked, where is this less than 3? Or in other words, where is this less than 0? This is less than 0 from negative infinity, including, or actually not including, but up to 2 minus the square root of 2. And it's less than 0 between, but not including, 2 and 2 plus the square root of 2. Had this had equality, I would have included a solid dot at these x-intercepts. But because it doesn't, they are open circles just like the vertical asymptote. This concludes the video notes for day 2 of 2.6. Have a great day.